Measure of central tendency. A value that represents a typical or central entry of a data set. The most common measures of central tendency is the mean, median, or mode. The mean is the average. So to find the mean, you're going to sum up all the data entries and divide by the number of entries. So when we talk about summation, the symbol here for summation will be the symbol that's next to the x variable. And the x variable represents the data piece. So you would sum up the data pieces. If we're working with data that is the population, for the population mean, we'll use the symbol mu, the Greek letter mu, to represent the mean. So again, you would sum up all the data entries and divide by the number of data entries. If we're working with the sample mean symbol would be x bar. So similar, you would add up all the sample pieces and divide by the number of samples. The median is the value that lies in the middle of the data when the data set is ordered. So you would have to order in numerical order. If the data set has an odd number of entries, it is the middle data entry. If it has an even number of entries, it is the mean of the two middle data entries. So you would take the two middle data entries, add them together, and divide by 2. For the mode is the data entry that occurs with the greatest frequency. So if there's no entries that repeat, the data set has no mode. So if there's no repeating data, then there's no mode. If two entries occur with the same greatest frequency, each entry is a mode or a bimodal. When we're comparing the mean, median, and mode, the advantages of using the mean, it takes into account every entry of data set. The disadvantage of using the mean is it's greatly affected by outliers. And what outliers are, it's a data point that is distinctly separate from the rest of the data set. An example of an outlier could be if I was to get the average of a test grade in my class and there is a 0 test, that would be an outlier. The mid-range of the data set is the measure of the center, that is the value midway between the maximum and the minimum values in the original data set. It is found by the following formula, which is the max data value plus the min data value divided by 2. That would be your mid-range. So when we're doing rounding for the measure of the central tendency, we're going to be using the round-off rules. For the mean, median, and mid-range, you carry one more decimal place than is present in the original data set. Meaning, if you have all whole numbers, then you would go one decimal place when you're identifying your mean, median, and mid-range. If it was 2 decimal places, you would go 3 decimal places, and so on. For the mode, leave the value as is without rounding, because values of the mode are the same as some of the original data values. So let's do an example, and we're going to be using the TI-83 or 84 calculators. So when we're using the calculators, I'm going to be showing you step by step on how to enter it into the calculator and how to find the values. So we're going to be doing this example, and we want to find the mean, median, mode, and the mid-range. So we have this data set, and we're going to enter it into our calculator. To enter it into the calculator, you're going to go to the stat key that I've circled here on the calculator. So you want to look for the stat key. And number 1, when you get into that menu, says edit. So whenever you're entering in new data, you want to use the edit menu. So you're going to hit enter, and it will bring us into the next slide, which has the L1, L2, L3 representing naming the columns. Now, a key note here is if you have data in the L1, you want to clear the data out to enter in new data. To do that, you're going to arrow up so that your cursor's on the L1. It should be blinking on the L1, and then you'll simply hit your clear button. Make sure that you hit the clear button. Never use the delete button. So hit the clear button and it will clear the column. Then you're going to enter in the data by going into the first data spot, hitting the 13 and hit enter, and it'll get you to the next data spot. So you want to make sure that you're entering in all the data. Once the data is entered, then we're going to calculate. So to calculate, again, we're going to the Stat menu, and notice you have to arrow over to the CALC, which represents calculate. And we're going to use the first option, which is the 1var stats. We're going to use that to do the calculation. So you're going to hit enter, and once you hit enter, you're going to see this screen. Now for the newer calculators, it says list, and it's asking us which list do you want to use. If you put the data in list 1, you want to make sure that it has list 1 here. For the older calculators, you might not have this menu, so you're going to actually have to type in the L1. And to do that, it's on your calculator. You'll have to use your second key, which in this picture is the yellow key, to get up to the L1 option. And the L1 option is in yellow letters above the number 1. Now, in the TI calculators, the coloring might be different, but it's still the same process. You're going to use the second key, and the L1 will be above the 1. And then you can hit enter. Once you hit enter, you're going to see this screen. And remember, the X bar value is your mean. So in this case, if you tried this example, your mean is going to be 8.4. And I applied the rounding rule here because the decimal went off indefinitely, but we want to apply the rounding rule when we're finding the mean, median, and mid-range. And the rounding rule, because these are all whole numbers, means I have to go one decimal place. So I end up getting the mean here is 8.4. Now to find the median, you're going to have to use the scroll down button. So you're going to use that arrow down, and you're going to see we have the min, the Q1, median, Q3, and max. So what we want is the median, and the median is that MED. And again, I'm using that rounding rule, so I get 8.5 as my median for this data. So now I'm going to find the mid-range. And remember, the mid-range is the max plus the min divided by 2. So in this case, we have the min value was 3. The max value is 13. So I'm going to add 3 plus 13 and then divide by 2. So my mid-range for this example would be 8. When we're talking about finding the mode, sometimes it's just easier to look at the data and pull the mode out. But we could do it in the calculator, but it's not going to simply identify the mode. We're going to have to look back into the list. So if you choose to do it in the calculator, what you would do is you would go to that stat key again, and you would choose number 2 to sort the list. And you would choose to put in, you want to sort the L1 where you put the data, and then when you go into that sorted list, you can see which number is repeated the most. And in this case, the mode would be 7. So again, sometimes the mode is just easier done just by looking at the original data versus looking at the calculator. Pause and try. So in this case, you should have gotten your mean, and again, I'm representing it with X bar because it's a sample, so it should be 14.8. And then we have the median is 15, the mid-range is also 15, and your mode is 16. Now we're going to work with a weighted mean, and most grades are based on a weighted mean. So when we're talking about a weighted mean, the mean of a data set whose entries have varying weights. We're going to find the sum of the data values times the weight of that data value. And then we're going to divide it by the sum of the weights. So the W is the weights for each entry of data, X. So a key note here is that our weight is going to be either a percent, it could be a fraction, it could be a decimal, or it could be the frequency based on what is given. So we're going to do an example here, and this is an example based on grading system. So you're taking a class which your grade is determined from 5 sources, and it's given me percentage, 50% for your test mean, 15% for the midterm, 20% for the final, 10% for computer lab work, and 5% for homework. And then you're given the scores that were earned. So you have an 86 mean for the test, 96 for midterm, 82 for final, 98 for the lab, and 100 for the homework. So the first thing I like to do is just organize what's here. It gave me my test mean, and my test mean was 86, and the weight is 50%. And I'm converting it to a decimal because our calculators need percentages in decimal because there's no percentage on the calculator. So you want to make sure you know how to convert a percentage to a decimal. And then we have the midterm, the final, the lab, and the homework, all the grades, and then you have the weights. So now we're going to do this in our calculator, very similar to the previous example. We're going to enter in the data, and to enter in the data, you're going to go into the list. To go into the list, you choose the stat function on the calculator, and we're going to edit. So this is where we're going to enter in the list. Now remember, to clear a list, you're going to have to arrow up to that L1 and hit the clear button. Once you hit the clear button, it will clear the data that's in there. And then you want to arrow back down and enter in the data. So we're going to enter in both lists. You're going to put in the scores, the X values, into the list 1. And in list 2, you're going to put in the weights or the percentages. So once you've entered in the data, the L1 and the L2, then you're going to do the calculation. Now notice here, when you do the calculation, you're going to the stat menu and you need to arrow over to calc. Choose the number 1, which is that 1 var stat, and you're going to hit enter. Now for the newer calculators, you're going to see list 1, and you're going to have to enter in, make sure that the L1's there. But notice, because we have 2 lists or 2 columns with data in it that we're calculating, make sure that the frequency list, you have the L2 column in there. So to find that L2, again, it will be on your calculator. You're going to need to use your second key, and it will be above the 2 to find the L2. And if you have the TI-83 calculator, you won't have this screen, but what you will do is type in L1, and then you need a comma, and then type in the L2. You'll notice that the comma is right above the 7, the number 7 on the calculator. So make sure you separate the L1 and the L2 with the comma. Then you'll hit enter, and once you hit enter, you'll see that you'll have the X bar, and in this case we get 88.6 as the mean for this grade. And to answer that question, did we get an A? And we did not get the A because it's not a 90 or above. Pause and try. So again, I'd like to arrange the data here, and our data or our X values are the scores averages, and the frequency or the weight would be the enrollment. And now you have your list 1 and list 2 that you would enter into the calculator, and you should get a mean of approximately 73.1. And again, I'm using that rounding rule here for the answer. So now we're going to talk about the mean for a frequency distribution. Now remember when we did the frequency distribution table, we used classes or intervals. So in order to get the mean of a frequency distribution table, you're going to need the midpoint. And that midpoint is found, remember, by adding the lower limit plus the upper limit and dividing by 2. So you're going to find the midpoint for each class, and then you're going to take the frequency and multiply it to each midpoint. And then you divide by the total number of data pieces. So that's how you're going to find the mean for the frequency distribution. So let's see what this looks like. So I have this frequency distribution. I already added in a blank column for the midpoint. So you might not have the midpoint column. So you're going to have to do it off to the side. And again, to find the midpoint of the classes, you take the upper limit or the lower limit plus the upper limit and divide by 2. So I end up with 12.5. And to find all the other midpoints, you can use the class width. And in this case, the class width is 12. Remember, 19 minus 7, that's the two lower limits, will give us 12. And then you add 12 and you all the way down, and you have the midpoints for each class. Now you have the midpoints and the frequency. And we're going to use the calculator again. So we're going to take it and we're going to put it into either the TI-83, 84, whatever instrument you have, and we're going to do the calculation. Now a key note here is when you're doing frequency distribution and you're trying to find the mean, you always have to put your midpoint value in the L1. Make sure L1 has the midpoint value, and then the L2, you'll put the frequency in. And you're going to put it in, L1 will be midpoint, L2 will be your frequency. And then you're going to do that stat calculate and choose number 1, and you're going to do the calculation. So in this case, the mean for this frequency distribution would be 41.8 minutes. Pause and try. So remember that midpoint has to go in that L1 column. The frequency will go into the L2, and then when you do your calculation, you're going to end up with your mean is 36.2. So now we're going to talk about distribution shapes. When we're talking about distribution shapes, the frequency distribution can assume many shapes. The three most important shapes are positively skewed, symmetrical, and negatively skewed. So the first is the right skewed. When you have right skewed, most of your data is collected to the left, and you have your mean is larger than the mode or the median. Bell shape or symmetrical skewed is everything is equal. And then you have the left skewed, and that's where most of your data falls to the right, and your mean is lower than the mean and median and mode. So a key note is, in a skewed distribution, the mean is further out in the tail than is the median. The mean is pulled in the direction of possible outliers. So when we're talking about the range is going to be the difference between the min and the max value of the data entries. So when we want to find the range, you're going to use the max value and subtract the min. So in this case, we have a corporation that hires 10 graduates. The starting salary for each graduate are shown. Find the range of the starting salaries. So in order to find the range, you're going to have to use the max value and subtract the min value from it. So our max value here is 47, the min is 37, and when you do the subtraction, you see you get 10. And because they're talking about that thousands of dollars, we end up with 10,000 is the range. Pause and try. So in this case, you should have gotten the range is 24. What a deviation is in statistics. It's the difference between the data entries and the mean data set. So in order to find the deviation, you're going to need the mean. And then you're going to take the mean and you're going to subtract it from each data set. That will be the deviation. So the population deviation would be your x variable is going to equal the x minus your mu. And remember, mu represents the mean for the population. In the sample, you would be using the x bar. So when we're looking for the population variance or the population standard deviation, we would be using these formulas. Now notice that the variance has the sum of the deviation squared divided by the number of data pieces. And that sum of the squares is an abbreviation, that SS lower x. Once you have the variance, to find the standard deviation, you simply square root the value you got. So a key note here is the standard deviation tells us how closely the values of the data set are clustered around the mean. If the data is close together, the standard deviation will be small. If the data is spread out, the standard deviation will be large. So the symbol is called sigma. So when we're talking about standard deviation, we're going to be using sigma for the population standard deviation. For the sample variance or sample standard deviation, the difference in the formula is we're going to have n minus 1. And that n minus 1, this is known Bessel correction. This corrects the bias in the estimation of the population variance. And some, but not all, of the bias in the estimate of the population standard deviation, but often increases the mean squared error in these estimates. So this formula is showing us how to find the standard deviation if we have a sample. The round-off rule for measuring a variance is similar to the mean, median, and mid-range. When rounding, the values of the measure of variance carry one more decimal place than presented in the original data set. So it's the same as the median, mean, and mid-range. So we're going to be using the calculator to find the standard deviation. It's important to know that that calculator uses that formula that was shown, but the calculator will do the work for us. So we want to find, in this case, the range, mean, variance, and standard deviation. We're going to be using the same menus that we've been using for the previous exercises. You're going to go into your stat and we're going to edit, we're going to put in the list of data. Now again, if you have a list in there, go up to the L1, hit your clear button and it will clear it. Enter in the data, in this case the 5168512, into list 1. Then we're going to hit the stat key again and we're going to arrow over to calculate and we're going to use the 1 option. So you see here, once you do that, in your home screen you're going to have the information we're looking for. So if this was sample data, our sample standard deviation would be that 2.7. If this was population data, we would have our sigma, or our standard deviation, would be that 2.5. So when we're using the calculator will do the standard deviation. To find the variance is the square. So in order to do that, we need to use the calculator vars button. And you see the vars button is close to the arrows, and you want to choose number 5. It says statistics. That's where we're going to find the different statistical symbols. So we're going to use the statistic button, and you're going to see the number 3 has the sample standard deviation symbol, and the number 4 has the population standard deviation symbol. So to do that, you're going to choose either the 3 or the 4, whether you're getting the sample variance or the or the population variance, and you're going to use the square button. So you're going to use the square button. If you chose 3, you're going to choose 3, and then you're going to hit the square button, which has that x square, and you're going to hit enter. And you should come up with 7.3 as your sample variance, or 6.3 as the population variance. So for the variance, you have to do a couple extra steps to find it using the calculator. Pause and try. So you should have gotten the range is 70, your mean is 186.1, your standard deviation or sigma is 18.4, and the variance here is 340.1. Pause and try. Now notice here, this is a sample, so you got to make sure that you pull out the right information. The range is 10, your x bar is 17, your sample standard deviation is 2.6, and your sample variance is 6.7. When we're doing measure of position, we're going to be talking about quartiles, and quartiles divide an ordered data set into 4 equal groups with about 25% of the values in each group. The second quartile, the Q2, is the median of the data set. It divides the data set into lower and upper halves. The first quartile is the median of the lower half of the data set after you've divided it into 2 data sets. The third quartile is the median of the upper half of the data set. The interquartile range is going to be the difference between the third and the first quartile. So once you found the third and the first quartile, you can find your interquartile range. So you'll take the third quartile minus the first quartile, and you'll have your interquartile range. To find outliers, you'll use this formula. You're going to want 1.5 times that interquartile range. To find the lower outlier, you're going to take the first quartile and minus out the value you found by multiplying 1.5 times the interquartile range. To find the upper outliers, it will equal the third quartile plus the 1.5 times the interquartile range. So let's do an example here. And we're going to be using the TI-8384 calculators to do this work. So what you're going to do is the same thing we've been doing. You're going to go to your stat key, and you're going to hit enter, and you're going to enter in the list. And here I'm entering in the list of all the data pieces that were given. We're going to find the quartiles by going to the calculate button and choose the number 1 bars stat. And you're going to see you're going to have your mean and your standard deviation here, but you're going to have to arrow down or scroll down to find your quartiles. So you see here we have our quartile 1, our median, our quartile 3, and then you see we also have the min and the max. We've been seeing this screen from previously. So we're going to identify the quartile 1 and the quartile 3 to find the interquartile range. So I get the 1,699 minus 725, and my interquartile range here will be 974. To find the outliers, I need to multiply 1.5 times that interquartile range, and I will get 1,461. So now I want to look for my lower outlier by taking 1461 and subtracting it from my Q1. My Q1 is 725, and I end up with a negative value. So there is no values in my data set that is lower than a negative 736, so there's no lower outliers. Now I'm going to see if there's any upper outliers by adding that 1461 to the third quartile. And when I add that, I get 3,160. And if there's data pieces that are above that, that's an outlier. And in this case, we have an outlier of 4,450. Pause and try. So in this case, you should have got your quartile 1 is 58. Quartile 2, or median, is 62. Your quartile 3 is 63. The interquartile range is 5. And the outlier is 74.